stage is yours.
Right. So I will spend a little time talking through network automation in the network lifecycle and across the entire form of our networks. I think that one thing we're all well aware of, networks inherently are systems. They all have outages. We're constantly building to them, upgrading them. So the life cycle as we go forward is critical, and we need to embrace that. So a little bit of why is automating network life cycle so important. It is the single most cost of expense. We spend a lot of time thinking about CapEx. We all struggle with the existing legacy of our network, but how do we shift and build the networks that we're all up here talking about, networks of the future, when we're stuck in much of the legacy that we have today? So Analysis Mason went out and did a study. They talked to 20 top providers and tried to get a breakdown. Where is the biggest impact of automation? And not surprisingly, it is actually in network lifecycle. So how do I take my older network, go through MOPS and upgrade it? How do I roll out bigger networks as we go forward? And the other big areas are if I can take automation to reduce the labor time it takes, if I can take time to revenue, roll out services faster, from the time I buy equipment, go through a capital budget cycle, to the time I deal with supply chain until I get it deployed, it could be well over a year. So what can I do when I get a service as I buy capital to compress that time? And then another really important area is when you look at what causes an outage, what causes an error in the network, we think of weather, we think of today, security attacks, denial of service, but one of the biggest areas is actually people, the people that operate a network. As I go and I make a change in the network, did we fat finger, did we roll back an access list, or did something to get out of the maintenance window, but we left a vulnerability behind? Or did we get a kind of a config drift from what it was originally? And then how does that also impact mean time to repair? So I think it's important as we talk through technology, it's why are we doing this? And what is that compelling factor? Another interesting, the evolution of network automation. I think we can all think back to network management systems, and in many ways, many operators are still living in that first phase of network management. But then we brought in a whole new wave of software-defined networking, and how do I take controller elements and segment routing and PCE and bring all of those different new innovations and disruptions to our network and bring that into the network. We're spending a lot of time today talking about intent-based networking. And intent-based networking, I think in its early days, started with NetConf Yang, and there were some pioneering companies like TLF that went off through ITF and really moved NetConf and Yang forward as a standard into adoption. But it's evolved since then. It's understanding that suddenly the network isn't the source of my intended truth in the network. It's my intent system. It's more of a data model. It's more of a database structure. So how do I make that paradigm shift and not just set up intents from a configuration standpoint, but fulfill intents as I go forward? And the bigger area, and a lot of talk and a lot of early action, I think we see a lot of this come out of web scale, a lot of this come out of IT, is now we're getting into cloud native, we're getting into Kubernetes, and we're bringing each one of these new innovations, each one of these new disruptions into the space. And how do we embrace them? How do we bring them and get the most out of them to build these system of networks that are constantly changing, constantly breaking? In the days of trying to build 5 nines, 10 nines, and think your network's never going to break is throwing unnecessary capital in a situation that's probably solving a problem it's the wrong problem to solve. So just a little bit on intent-based networking. It starts with making sure I understand both intents from a service level and then my intents at a device level. I think the industry is well down the path of embracing Yang as my device level and to a large extent my service level modeling language through things like JSON or YAML. I can look at Yang models, I can define them. We're not nearly as far as an industry in deploying Yang models and doing this across our networks, but I think we're at a point where everyone agrees we're going down that path. It makes a lot of sense. Then we think through how do we automate and roll that out. The other part about networks is they're all multi-domain. We're crossing both horizontal domains of IP and optical that are coming together and data center, and then multi-domain horizontally as we go from mobile networks into consumer networks, access networks, into the edge. We all go from front haul, mid haul, all the way through our backbones into data center services, and then bring this together holistically. So how do we manage and automate across those different domains? The other important part of intent-based networking, it's not just defining and pushing configs, it's how am I aware of a network that changes. So as I do have network outages that occur because of fiber that's dug up or different events, weather-related events, as I have security-based events that occur in my network, as I look at traffic patterns that continually shift, how do I appropriately ingest those services so I can deliver this? You think about 5G slicing and transport slicing. There's an element that has to be delivered in the cloud, an element that has to be delivered on the mobile side. But when you get into the transport slice, I also need to be aware of latency, bandwidth requirements. You don't want to be constantly changing the way you're setting up your network and optimizing, so you need the right level of thresholds there as well. And then make sure that you're doing all the assurance so you can do those dynamic shifts. So intent-based networking is part of the puzzle. It's not enough. There's still fundamentally a need to do workflow management as an underlying automation process here. So as we all build out our next generation automation platforms, we can get very focused on intent-based management, but workflow management in conjunction and synchronized is critical. And then you look at upper layer services when you get into assuring both my devices, my network, and my service assurance. And then how do I roll out new service fulfillment capabilities across that, and then build out infrastructure config. We get some somewhat basic use cases, but they are very, very common as I try to keep up with the pace of capacity, and I'm doing link aggregation, and I'm adding to a lag the ability to scale up across that domain and do that both in an intent-based world. So I'm not creating service fulfillments in one silo, and then I'm doing my normal operations and installation in a separate silo. And then the other piece here is we're always going to have a classic legacy network. I have spent my time in the vendor community, and I've also worked for 2 very large carriers in the US, second largest cable operator, and the largest mobile operator as well. And every vendor I've been to and every vendor I've worked with, or supplier or service provider, there's been too many legacy devices in the network, too many different vendors. So I need to always do consolidation, move to netconf Yang type systems, but then be able to also support classic SNMP capabilities. And this is bidirectional, so I'm going to have to northbound be able to look at syslog and SNMP traps and gRPC from a telemetry standpoint, and make sure I can move both northbound and southbound. So I touched on workflow management. This is a critical capability. There's a lot of good tools out there. We do a lot of work building our workflow in with leveraging Mistral in that space, but making sure that we can take different tasks and then build those from both pre-checks, automating a different sort of change in the network, and then doing post-checks as well to verify that we've done things properly as we go forward across the network. The other element that's critical is building a good model-driven infrastructure. So understanding that I need to build both a model of traditional classic devices that are not doing netconf today. So I need a variety of different adapters to do those translations and do those data mapping models. And then I need to go and make sure that I can go directly down using netconf. And if you look at it just from a configuration standpoint, it's a somewhat simplistic, oversimplified model. You also need to look at this model from how do I receive information up so I can understand state changes as well. If I'm getting SNMP traps, if I'm getting syslog messages, if I'm getting information off Kafka that are changing network dynamics, I also need to be able to change my model so that I'm not in a situation where every time I push to the network, I want to sync my model with the network, which is traditionally where many people start when they go through a model-driven network. But the size and the complexities of our network, when you try to sync something that's very large, I don't care how you've designed your systems, there are massive delays and there's all sorts of issues. So you need to build ways that you can scale and sync segments of the network so that you're constantly building and staying in sync to the intents, but not getting into a database lock issue, which will slowly create vulnerabilities in this conceptual model as you go forward. Another really important part, and I think a lot of this was done early on, and we talked a lot yesterday on segment routing, but the concept of where do I take path computation engines, and if I'm going to use things like BGPLS, or I'm going to look at PC both at a client level and PCEP at a server level, I need to not just build this into my routing domain for traffic engineering, I need to integrate this into my automation platform domain as well. So there's a lot of work, and I think the industry is moving to SRv6. I think it's a journey. It's going to take many, many years, and we probably will never see all networks move in that direction. So the importance of looking at traditional traffic engineering methods, if it's RSVP, TE in a network, and then segment routing as well, or segment routing v6, and then bringing that hybrid network together so I can have views of that path computation SDN arrangement, and then bring that across all of these different environments. Another really important part here is interoperability of vendors, and then interoperability to make sure if my vendors are not all on the same version, how do I move between all the different routing, traditional segment routing vendors in this space? So the multi-vendor piece is critical. And then how do I pull information back up from a telemetry-based standpoint? If I'm using gRPC or Kafka to get my telemetry type information, how am I maintaining that and then using that to do simulations to make sure that I'm working through all the different capacity planning so that I can roll out a different service. So fundamentally, it's important that a PCEP traditional SDN controller for the network domain is tightly integrated in with the network automation system as well. So to kind of wrap up, at least from a pictorial standpoint, I fundamentally believe as we build through next generation network automation platforms, we need to look at those northbound layers. If it's orchestration, if it's service fulfillment, it might be customer portal, it might be a higher level 5G orchestration system. How do I look at that upper level and then make sure my automation platform is providing REST-conf APIs, the ability to make requests or to make intent-based requests of the network automation platform. And then from that, fulfill those network automation pieces if it's going through configuration type apps or changes or network changes. Or as I'm going through optimization and control, how do I understand what intents I took? If I'm going to take a reservation, I'm going to fulfill the reservation, I then need to maintain that reservation over time. So the optimization and control apps within that capability of PCE and some of those other elements are critical that they're integrated here. And then a whole suite of understanding assurance and analytics. We traditionally grew up with network management systems that focused at red light, green light, yellow, clicking on alarms and alarm correlation, and then moved into more analytic-based systems. But in some ways, these are starting to silo, and we need to make sure that those are more tightly integrated because there's a lot of really valuable information on the assurance and the analytics side that we're going to need for closed-loop automation to make sure we're going through and making each one of those different adjustments across the network. And on the southbound side, it's critical. This network automation can never be a single vendor siloed implementation. All networks are more multi-vendor. There are no brownfield service provider networks. No greenfield service provider networks. All networks are brownfield, and all networks are multi-vendor intrinsically. So we need to make sure that we're building solutions and thinking through if it's the variety of different router vendors, if it's different optical vendors. We've been very focused at TAPI as a method to make sure we're talking from our controller capabilities down into different optical controllers and sharing that information. And then making sure that we're able to go across those different domains as well. So as we go into the data center, go across the core, go out through access, we're covering each one of those as well from a technology standpoint. And the other important part is making sure we embrace and go down the path of Kubernetes. So there's been some talk today of GitOps and taking a lot of those traditional DevOps ideas, but bringing those more into the network so that we can start to build version controlling of network devices or version controlling of services, even version controlling of more of a representation of a service, so that when we do have changes or outages, we can roll back to understand those. The other part here is around IP and optical. Fundamentally, I've probably, as many of us, been talking about IP plus optical, it feels like for 10 to 15 years. And ultimately, when we had some of the early ideas, we always got stuck from an organizational standpoint and a budget standpoint. If you have different groups that have different metrics on their bonuses of what I'm responsible for, both in spending CapEx, in deploying projects, and then those operational boundaries. Nobody likes to get a text when there's a network outage, and the first thing you want to check is it my area of the network or if it's someone else's? If it's someone else's, then I can rest. I want to be informed. If it's in my area, it's a bit of more of a panic, make sure I have the best people on it. When you bring IP and optical together, it merges right down the middle of those traditional boundaries we have on most customer provider fronts. I believe 400ZR is, for us, game-changing, mainly because of the economics. I view 400ZR as being driven primarily from the large web-scale providers going back into the optic transceiver companies to drive those standards. But the dynamics of taking 400ZR, putting it into a router, is one of the most disruptive financial changes for what we do on a transponder. And I think we'll ultimately see transponders move down. And then from those transponders, we're going to then see at some point a network element be a router or an optical device merge. This is probably 10 to 15 years. But I think we're going to see all these different IP plus optical use cases come together. So these are some of the most common network automation use cases I see. So we see in a lot of cases across service fulfillment, a lot of provisioning, obviously. I talked about the IP plus optical use cases. I think we're going to start to see those as we have the domains come together, take more traction. But we're seeing a lot of closed loop optimization of how do I bring telemetry and then add different elements to a lag. I think there'll be a time when we get into what we call elastic lag, where I'm not only just doing this at a 10 gig, 100 gig routing standpoint, but I'm then initiating a kickoff or an automation into the optical domain as well. So in summary, as we look at automating the device lifecycle, first and foremost is to make sure that you're working on building an open programmable platform. It needs to be vendor agnostic, but it needs to be coordinated. It needs to be thought through to make sure there's pluggable extensions, that it's truly going down the path of intent-based, that it has open APIs, both northbound and southbound across that. Second is to make sure that it's integrated in with those resource control capabilities from a path component. Those are not necessarily separate initiatives. There has to be a strategy to tightly pull those together. And then lastly, make sure as you work through network automation that it's a very vigorous prioritization on what's the biggest impact. Too much of network automation gets stuck as a science project. Too much of it gets stuck in a science technology CTO organization. And there's a lot of really cool things we can do with AI and machine learning. Sometimes we've made it too complex, and we need to take a step back and say, where, as an operator, do I have the biggest cost? And where do I have the biggest impact with automation? So with that, appreciate it, and I'll be around if people have questions. Thank you.